Graham Warwick. I'm the technology managing editor for Aviation Week, and I'm a journalist, been a journalist for 40 years. I was an engineer briefly before that, working for Hawke Siddeley on advanced Stovall, believe it or not. But I was a much better journalist, I think, than I ever was an engineer. So, but I have therefore covered the F-35 program from its inception, so it's great to be here today. And our panel is called Reflection on Partnerships within the F-35 Enterprise. So just open a few remarks, just say that basically everybody in this room and everybody who's watching us on live stream will have an opinion on the F-35 program. It's impossible not to have an opinion on the F-35 program. It's the Pentagon's biggest procurement program, but it's also this industry's greatest engineering effort. And like the F-22, I think that in time, once the programmatic dust settles, it will be recognized for the engineering achievement that it is, not just the effort, but the achievement that this program is. And here, as Jeff Babioni said, this today and tomorrow here at AIAA Aviation, we really do have, and the word was unprecedented, and I think it's true, we have incredible visibility into that effort through the papers that are being presented later today and tomorrow. I would really encourage you, if you can, to go see these. I've had a chance to read at least some of the papers. There's a lot of them. The overview was just extraordinary for me because it really reminded me what we've forgotten. We forgot why this program is the way it is. There's a very good reason why this program was set up the way it was, why the key characteristics of this program, like commonality, concurrency, multi-role capability in a relatively small airframe, why they're in the program, and it also explains why they became almost like the driving challenges of these programs, of this program. So if you go back to the beginnings, you really remind you why we did it the way we did, and then shows you what the consequences of that are. There's also some incredible insights into the challenges, and I have to say that the two of them that really stood out for me was the effort of the Stovall Weight Attack Team. Just an extraordinary effort over a very brief period of time to redesign the aeroplane to get the weight down across all the variants, major impact on the program, but also a better aeroplane out of that. And the other one that almost blew my head away was the weapons integration paper, particularly the challenges in designing the weapons bay. If you want to know how difficult it is to design this airplane, just read that one paper or go to that one presentation. You have no idea how difficult it was to get the weapons bay into this airplane in a way that would position this airplane to operate for the next 50 years. It's just an extraordinary challenge that you don't see looking at it from the outside. I will say that having read the papers, I'm really pleased to see that as a journalist, and it goes back to what Jeff said this morning about transparency, we didn't miss much as journalists. When the program had a challenge, I read through all the challenges that are listed in there, and the press was on top of them. This program, there is no program that's ever had to deal with that. Everybody says what a great airplane the F-16 is, what a great airplane the F-15 is. If you're a historian and you go back and you read about those programs, they all had tremendous problems, either in development or in early service introduction. No program of that scale ever goes smoothly, and the F-35 is no exception. But like the F-16 and the F-15 and the F-22, the chances are, the indications are, that we will have a truly capable machine at the end of this, that will all in years to come hold up as being the benchmark for what it does. So today we have all the people you really need to hear from about the F-35 program, across all aspects of the F-35 program. I'll introduce them and they'll talk to their part of the program one at a time. And then when we get all the way through, we'll then open up to questions at that point, but we'll let everybody do it. I'll only give a very brief introduction because part of their presentation is to explain their role or their involvement in the F-35 program so that you know that you that they know what they're talking about and that you can listen to them. So they'll explain that. So I'll only make a very brief introduction, but I'll start at this end and we'll work along. So the first person, our first presenter, speaker today is J.D. McFarlane. He is the VP for F-35 Test and Evaluation at Lockheed Martin. He has 23 years of experience on the program, from JAST through the JSF competition into the F-35 development and obviously the testing. He actually joined the Fort Worth division of General Dynamics in 1984 as a propulsion analyst. And of course, that part of GD became part of Lockheed Martin in 1995, and the rest, as they say, is history. And JD will now he's going to start off with a video, and then he'll walk us through the extraordinary testing accomplishments of this program. So, JD.
Thank you, Graham. I picked all my friends that at least had 20 years of experience on the F-35 program, so I appreciate all of them participating today. The F-35 program is vast and could not be done without a worldwide partnership. Lockheed Martin gets all kinds of credit when something goes wrong on the program. Graham will write his articles and say, the Lockheed Martin F-35 cost too much, took too long, whatever. And we maybe get more credit than we deserve when something goes great on the program. But we made a video that I'd like to start the program off with that explains that partnership and gives you a perspective on the breadth and depth of that partnership. So if this works, we will roll it. Okay, lots of partnerships. And if you stay through the F-35 track the next 2 days, you're going to get to see more videos. Every presenter's got an interesting video to show you. A little bit about myself. Went to Auburn University, graduated in '84. How many Auburn Tigers are in the room? All right, War Eagle. Got a master's degree at UT Arlington while I worked. My first real experience that was part of the F-35 program was program manager in the mid-90s on what we called an F-16 diverterless supersonic inlet. We're going to try not to use too many acronyms this week, but we call that the DSI. And you're here to hear some of the inside baseball stories, so I'll start with a little inside baseball story on the DSI. We were doing technology demonstrators at that time. We did a more electric airplane on an F-16, did a lot of manufacturing demos. Lockheed Martin decided we're going to put this DSI on the X-35. And we had just been through the development of F-22, and even though it was a fixed geometry inlet, it has a diverter, it has a bleed system, it has a bypass system, it has moving parts, it's difficult to manufacture, and we had been working on this technology called the diverterless supersonic inlet, or the bump that you see on F-35 today. I got to lead a team that flight demonstrated that on an F-16. And in a couple years, we went from paper concept, wind tunnel testing, we did the design work, we built all the parts, mainly in Fort Worth, all new skins, all new frames, borrowed an F-16 from the Air Force, took that inlet off, got some tooling out of the boneyard, built a new inlet fixture, built that and put it on that F-16. Did the flight demonstration program in December of '96, flew 12 flights in 1 month, flew all the way to Mach 2, and high angle of attack really thoroughly demonstrated that this could be applied to the Joint Strike Fighter program. So fast forward into spring of '97, we had integrated the DSI on X-35, and we were doing a wind tunnel test of the configuration. And the skunks, they're kind of agile and secretive and quick. And we showed up at the wind tunnel facility, and not all the skunks wanted the DSI. And so a couple of the aerodynamicists had built a carrot inlet, which is the same kind of inlet on F-22. And they pulled it out of their suitcase and said, hey, we're going to test this configuration next. So what in the world are y'all doing? We're going with the DSI. And so they got it on the wind tunnel model and tested it, and lo and behold, it had some improved aerodynamics. The inlet performance wasn't necessarily better, but the aero performance on the airplane had changed a little bit. And so we couldn't figure out what the deal was, and they were ready to change configurations back to that. And so we called up the general manager of the program at that time, and Dave Wheaton, and said, Dave, the skunks want to put the carrot inlet, on the airplane, and we want the DSI. We need some help. So he directed them to go back, every single piece part that had been changed on the wind tunnel model, figure out what the deal was. And we found out some non-inlet part had caused the change in aerodynamics. We changed that and put the DSI back on. So we almost lost the diverterless inlet on the program in '97, but anyway, it survived, and we optimized it during the development phase, and that's what's on the airplane today. It has the benefit of lower weight, lower cost, and low observability. After that, I came onto the program and worked on the preferred weapons system concept, led the propulsion team. We won the program and led the propulsion IPT for about 4 years, and then was called to the air vehicle team, was the deputy for that when we flew the first airplane, AIAA, got to work that while we got that airplane flying, and then became the vice president for air vehicle development. I got to go up to Pax River when we were flying the very first airplane that we took up there, aircraft BF-1, and I got it to go through its first vertical landing. And then after that, got moved over to Vice President of Test and Verification, which I've had the honor to lead for the last 9 years. So that's my quick introduction, and my slide to introduce what I'm qualified to talk about is the Integrated Test Force, or ITF. And we call it integrated because it truly is an integration of the Lockheed Martin, Northrop Grumman, BAE Systems team, but we have Pratt & Whitney and Rolls-Royce at Pax River, Pratt & Whitney at Edwards Air Force Base. And then you cannot do a flight test program without a tremendous amount of government support. And actually, half the team at Pax River and half the team at Edwards Air Force Base is made up of our government counterparts, a mix of civilian and military personnel. The size of the test team has varied over time, but at its peak, we had about 1,000 individuals at both test sites, half Lockheed Martin contractor team and half government. That team, as Jeff mentioned in the opening, conducted 9,235 flights, but who's counting? We did get to count. A lot of people were interested in what was going on in flight tests, so count we did. Every single night we put out a report. Here's what we did today, here's what we got planned tomorrow. That report made it to the CEO of Lockheed Martin and to the PEO, the Program Element Officer, the General or the Admiral running the Joint Program Office every single night, including Saturdays and Sundays when we flew on the weekend. So my favorite day on the program was April 11th of this year, the last day on the last flight of the F-35 flight test program. That was the last report we had to do. So I was excited about that. My team was very excited about that. But it's, Jeff mentioned that it's been the most comprehensive flight test program ever attempted. Well, that's because it was 3 airplane programs at the same time. And we've been to 6 aircraft carriers, 3 for the Stovall variant, 3 for the carrier variant. We've been to Lakehurst, New Jersey, which has a ship suitability testing facility. We've been down to Eglin Air Force Base to McKinley Climatic Lab, where we've been able to test the F-35 in multiple climates, and of course all the ranges that we have on the West Coast at Edwards in the Atlantic Test Range for Patuxent River. 9 airplanes at both sites, so we had 18 airplanes to execute the flight test program. So that's my summary, and look forward to any questions spanning those 20 plus years, or especially about flight test. And I will turn it over to John Mazer from the JSF Program Office.
So yeah, so John is he is the F-35 foreign military sales lead in the Joint Program Office, which we'll all keep calling the JPO. And he has been in the JPO supporting international sales for over 20 years. So and this is a truly international program. And before that, he worked as the Deputy Undersecretary of the Air Force for International Affairs. So he's obviously a man with a view on the rest of the world. So John?
Thank you very much. I'd like to say thank you for inviting me here today. As you can see in my little resume there, I actually have a degree in aeronautical engineering, and always thought AIAA is kind of where the global international or global community comes together to talk about airplanes. So this is pretty cool for me. I combined that with a degree in political science, international affairs, because I thought everything would work better if we would work together. So landing in the F-35 program office was kind of the aim for my whole career, really. I started out at Wright-Patterson Air Force Base when the F-16 was in its heyday, and everybody I knew wanted to be on that program. They wanted to be on the international side of it. They wanted to be on the cutting edge of technology. That was where people were trying to put their careers. So when the F-35 was in its infancy, and you were watching it come up in Aviation Week and all the other stuff, it was like, that's going to be the next one. That's going to be an opportunity. And I just happened to be in the right place at the right time, working over in the Secretary of the Air Force for International Affairs, doing negotiator for international cooperative programs, and opportunity came up to be a negotiator for the Air Force for this program. So I slid into that, and that eventually landed me a job in the program office as a country manager for on the partner side. That's all we had at the time was some partners. And so in the early days, well, I guess to describe the program, I would say it is an international program. I think that describes this program start to finish. When I came in, it was under the concept demonstration phase, and we wrote an MOU with various partners to describe how they would participate, how we would all participate in the program. During that part of the program, we had to be in constant discussions with Lockheed Martin primarily and with Pratt & Whitney as we were describing that this was not going to be a work share program. This was going to be a best value program, and any company that wanted to work on this, they had to prove themselves that they didn't just earn the work because their country had bought into the program, and that it was felt would drive up the cost of the program, but rather they had to convince us that it was best value. And quite honestly, they had to convince Lockheed and Pratt & Whitney they would be best value. It was industry's job to run around the globe seeking out those best value partners in industry. That led us into the SDD phase that you've heard described, you know, the system design and demonstration phase that we've been all working on for the last 15 years. And we wrote the MOU that described that. Well, we had only just caught our breath from finishing the negotiations on that when we said, wow, this program is heading into production phase, sustainment phase. So we turned right around again and started negotiating production, sustainment, and follow-on development MOU, which is going to lead us, keep this program together for the next 45, 50 years. To flip that over, so I had the opportunity to be a country manager inside the program office. That was to ensure that those countries got access to the information they needed to, they were in the meetings that they needed to, that their senior leaders had the information that they needed, working with industry to keep an eye on what kind of industrial participation opportunities were given to those countries. And about that same time, we started bringing in foreign military sales countries, giving them a taste of what it could be, what they could buy in the future. Got to the top of that part of it and moved over to become a deputy for the entire international program inside the program office. So that's partner side, international cooperative side, and then foreign military sales side. And then when our lead for foreign military sales was retiring, I jumped on that chance because for me that's the part that's really going to be taking off for the next 20 years, much like the F-16 program did. And I think as Jeff pointed out earlier, we've got 3 customers today. with Israel, Japan, and Korea, but we are regularly talking to another 5 customers, and there's twice that many that are expressing interest in various touch points through the U.S. government. So this, I went through a bunch of our international slides to try to winnow it down to what describes the international program, how would I describe the international program. And I kind of landed here because, as you can see in the inside circle, there's the partners. And the U.S. is one of those partners. We've signed the same agreements with those countries. They're not bilateral, they're multilateral agreements. So, for instance, the production, sustainment, follow-on development MOU that I mentioned earlier, that's going to last for another 45, 50 years. That took us 3 years to negotiate that thing, to get all 9 partners to agree on that. And whereas you see the 3 services at the top, those are all combined into one partner, and that's the U.S. government. So if you want to take just that inside circle, and all of those countries have a seat inside the program office itself. They all put national deputies, generally it's a colonel, representing their military in there. Some of the countries will send a civilian to do the same thing, as it's an acquisition program for them. And we sit shoulder to shoulder with them. And then they have folks that are distributed through the different engineering or sustainment or financial aspects of the entire workforce. They're out participating in the test program. And so every single day there are over 100, I think it's 150 of these international partner folks wandering around in the program office, just like the U.S. folks. And so you can't escape the fact that this is an international program. The other part of that I would tell you is whereas we negotiated the CDP, SDD, and the production, sustainment, and follow-on development MOUs, we also extended those to JD's area for the test program. So we've had several countries that have been integrated into that test program. Training, we've written international agreements to accommodate the training program that we're going to have so that we can pool our training assets and try to make this thing as inexpensive, as efficient as possible. We've got foreign military sales in there. They don't sit inside the program office, but they're just outside the program office so that they're in easy walking distance and easy for us to touch and them to touch us as they explain what their needs are, and we try to make sure those needs are accommodated. So I guess what I'm saying is that this is it's a complicated program. Just on the sustainment alone, it was decided a couple years back that the U.S. government would own the spare parts to this jet as we do a global sustainment solution for this program. So all of those parts are actually badged U.S. owned, and they stay that way until they get on a partner or an FMS customer's jet, whether they're a partner or an FMS customer. Just that aspect alone of this program was years in the works. As we tried to convince ourselves, we had to convince the Pentagon, we had to convince Congress, we had to convince the partners that this was going to be the most cost-effective way to maintain this aircraft for the next 45 years. So that broke new ground. So when people say, Mazer, you've been in that program for 20 years doing all this, just international, how can you stand doing the same thing for 20 years when people turn over their jobs every 2 years today? It's like, this program is nothing today like it was 20 years ago or 15 years ago. It's constantly evolving. The landscape for the international part is constantly evolving. And so every day we've got a new set of problems that come scooting across our desk that we have to reach out and try to find some workable solution for the Pentagon, for Congress, for industry. So it has not slowed down in those 20 years. It just keeps accelerating. And I think we're going to continue seeing that for the next 20 years. That's all I've got.
Thank you, John. So have you picked up any languages along the way?
You know, absolutely not. I got asked some years ago, why don't you guys learn a language? And it was like, well, which language would you like me to learn? Because I've got 7 different languages banging around in my office right now. So no, I've almost avoided that.
So our next speaker is Eric Brannion, and he is Vice President for F-35 Supply Chain Management at Lockheed Martin. And he has been with the F-35 program since 2004, and as you'll see in a minute, he's held several positions on the program over that time. Eric's been with Lockheed for more than 35 years. He also worked on F-22, satellites, and other complex systems. So Eric, over to you.
Thanks, Graham. So 38 years, it's probably more like 60. I was always the neighborhood kid that was building, flying, and often crashing model airplanes. That eventually went into, I got my pilot's license. I fly both gliders and powered planes, and then culminated in building my own experimental aircraft, where that kind of provides a pretty good background of what you need to know in this industry, because you have to get through design, you have to build parts, you have to build a production build sequence, you have to integrate propulsion, you have to integrate avionics, you have to get to your first flight, and you have to go to a flight test program. Surprisingly, it took me 18 years to do that, which is exactly where we are in the F-35 program. So there's a little bit of precedence there. I am an engineer by training, but if you look at the program experience I got down below there, it shows a lack of being able to hold any kind of job for any period of time. As Graham said, I spent a lot of time on satellite programs, propulsion, and then I got to work on the F-22 for about 3 years, working avionics on that. But you can see I'm a mechanical engineer by design here. And one day I got a call to say, hey, would you like to join the F-35 program? Okay, all the previous things I told you about loving airplanes, there was no place in the world you would want to be other than the F-35 program. So I started there on mission systems, and that was an incredible kind of point to be in the program. 2004, there wasn't a single airplane sitting on the ramp. We only had a little bit of software design. We need to go put software in an airplane and avionics so we could go do a first flight. And we were about 2 years away from first flight at that point. I remember standing on that ramp though and watching that first airplane take flight in Fort Worth. And it was it brought me to tears, because you go, look at all these people out here, 6,000 people just pulled off a miracle getting first flight of this fighter. Incredible period of the program to get to that. Now, some of you go, mission systems, there's a lot of parts on there. Now the airplane's flying around with about 8 million lines of code on that airplane to tie together all those sensors so the pilot can focus on mission and not just worry about getting an airplane flying and looking at all the various sensors in it. And that's turned out to be a game changer. But what's really interesting is how we are now changing it as we integrate new pieces. That original architecture, we had built in some elements of technical refreshes, and we went from one called 0.5, which is very, very basic, just fly and communicate kind of avionics. And then we went to a TR1 architecture, which got us through the first couple software and got us really out to what's on Marine Corps IOC jets right now. And now it's getting ready to go do TR3, which is the next step as we do follow-on modernization. But I look back at that, all the plug and play, and some folks out here are probably very familiar with the civil aviation industry and the big challenge of modernizing air traffic control and putting on ADS-B. I was an early adopter of my own airplane. I just decided one day in 2015 I'm going to go stick ADS-B in my airplane. It took me 3 days, $3,500. I don't know what all the kerfuffle is about that, but everybody else ought to just get over it, hook up, because once I had an iPad in my airplane, and I had all of air traffic around me, in-flight weather, you can't beat that for $3,500. Come on. So, it's just part of, being part of this whole industry. As I went through, several other things, the team in Fort Worth suddenly discovered, oh, he's not just an avionics guy, he was a mechanical engineer, so I got to lead air vehicle. That was a period of time where we're finishing up the drawings, 50,000 drawings across 3 variants, 50,000 hours in the, doing all the air, the evaluation in the test cells for the aerodynamics, and getting those 3 variants into their static and dynamic test phases. 3 variants. We did it in several places. We had A models over in the UK, B and C models in the United States, put them in those big test torture chambers where we spindle, fold, mutilate airplanes and force them to crack. Graham always wrote about the cracks. That's what we're actually trying to do. You're testing it to find them so they don't happen in the real world. But getting those all to happen simultaneously was an incredible engineering feat. I had the honor of leading the F-35 program as the deputy GM, stepping over heavily into the programmatic side. When Jeff told about going through Nunn-McCurdy breach, that was a big deal. It was all about engineering matched with programmatics, matched with funding, matched with confidence in the United States government, and how we had to restore that so we can continue forward that re-baseline program. And then they said, okay, Eric, you obviously have done program management. We're really ramping up production now. And I think Jeff showed that in 2011 we delivered 9 airplanes. That included the first production airplane that year. And that was tough, getting 9 production airplanes out that year. And then by the time I was done, we had pushed out 155 airplanes. The last year I was running production was 45 that year. Ramping up production. We talk a lot about all the exquisite engineering that went into this aircraft. What's just as challenging is setting up for production. Getting all the industrial engineers, the manufacturing work plans, the mechanics trained, the material flowing through supply chain to go build airplanes at rate. Anybody that's done it, and I watch with extreme envy what Boeing and Airbus do, cranking out 50 or so a month of 737s and A320 class airplanes. That's just an incredible feat in its own. All the choreography there was a learning experience by everyone and a really rewarding period for the industry in itself and all the partnerships we had to build. And finally they said, all right, Eric, you figured out how to consume parts for 5 years. Let's go see if you can go source parts. So I went from running 3 factories to run 1,600. Just a minor change in scale. But that leads me to one of the things that you look at is worldwide production. On the left-hand and right-hand side are 2 brand new factories. Mitsubishi over in Nagoya, Japan, and Leonardo in Cameri, Italy. They built F-35 factories. We build Lockheed Martin F-35s in both those factories. 10 years ago, neither of those factories existed. We had to go through all of the facilitization, building, property. In the case of Leonardo, it was greenfield. We had to go plow the land and dig up unexploded ordnance from World War I and World War II. Over in Nagoya, a completely different thing. They're very, very real estate constrained. It was a brownfield. They had to tear down and build up at the same time while we were starting the production activities over there. But in fact, these are facilities where those 2 companies work in partnership with us and deliver it. And it's really to the betterment of the whole program. Those 2 locations, those 2 cultures do things completely differently. Leonardo wanted to go use their own industry drills to go make holes. They're masters at doing dry drilling, no lubrication on it. Found out that that's a really great way to do drilling. It's more economical, and we've adopted that in Fort Worth. Over in Japan, just in their DNA, they are pathological about quality. And one of the things they did is they received any part that we sent them, forward fuselage, center fuselage, wing, aft. They would give us feedback on the quality escapes because they were masters at reading the drawing and knew what the parts were supposed to be when they arrived. And that's allowed us to get better as an industry in building those airplanes on time, on quality, on cost. So the partnerships are not just there to build the program. The partnerships are there really to make the airplane a better part because of the sum of all those pieces together.
Thanks,
Graham.
Thank you, Rick. I actually have a few examples to sort of add to that. So many years ago, I went to Fokker in the Netherlands, and I think they had been given the nose gear or a door or something like that. And the initial design from Lockheed, they said, we can do much better than that, because they had had a continuous, they'd done multiple gears from multiple different applications. So they actually had more recent experience than Lockheed, whose last gear door was the F-16 gear door. So that was an example there of a supplier bringing their experience. I went up to Magellan in Canada, and I mean, you have to see the precision which these airplanes are built to believe it. I mean, the machinery, the testing equipment, the cleanliness. But the interesting thing is, that's the way the commercial aviation is going. That accuracy of build is also what's going into commercial aircraft now. You know, you're seeing it feed in. And the other thing that strikes me as interesting is Jeff Babione earlier this year at the Lockheed Martin had a media day in DC, and he was asked about some of the quality escapes that are still happening in production. And he said, you know, some parts of this airplane, we are on the edge of being able to produce. And I think that's an extraordinary. This is an airplane that's been in development for 20 years, but it has pushed the edge so much that here we are, and we are still, you know, right on the edge of what industry can do to deliver this airplane. And it has brought industry so far forward in the process. You know, it is extraordinary how much it's driven the industry. Anyway, I'll go off my horse there for a minute. And our next speaker is Declan Holland. He is Vice President for US Business with BAE Systems Air Sector. So BAE is a principal partner on the F-35 program, and it supplies the aft fuselage, tail, and some other parts of the airplane from the UK. Declan joined the program in 2012 as the commercial director for BAE's F-35 business in the UK. He's been with BAE since 1996, and he has worked on some rival programs, including Gripen and Typhoon. So, Declan.
Thank you, Graham. So on the partnership theme that Eric has so correctly mentioned, take you across the Atlantic to the northwest of England. But actually, on the way, I'm going to stop a little bit over Dublin in Ireland, because that's where actually I was born, grew up, and I suspect there's not too many Irish people who have actually been in the program in terms of both from a UK perspective, but also in the US. So I went to university over in Glasgow University, and I did an avionics degree and a master's degree in electronics. And whilst I was there, I actually saw AIAA being advertised quite a bit in the university. And I thought, well, okay, I'm really interested in aircraft, but not actually that terribly knowledgeable. From a small town in Ireland, you don't get that much access to fast jets, etc., etc. So I thought, right, I'll join AIAA, fill out my sort of application, and translate some sterling into dollars and send it across. So right enough, a month later, got my application back, and the first periodical. So was with them for a number of years through the university courses, and it was a great way to sort of learn about the aerospace industry as it was at the time, and I suppose educate people in university as to what's current, particularly when you're from overseas. So I then started work in Marshall Aerospace for the first couple of years. Marshalls do a lot of work with Lockheed, did work on C-130s, Gulfstreams, various, mainly on aircraft avionics sort of integration, which was really good fun for somebody who liked engineering and being on aircraft. Then moved into BAE Systems. It was British Aerospace at the time, and I went to work at Bruff in the northeast of England, and that was to work on the Swedish program with Saab. So that's where we were looking at putting in place an export baseline standard 39 Gripen, primarily to compete actually with the F-16. So it did have some successes, but obviously knocking F-16 off its pedestal was never going to be an easy challenge. But we learned a lot of good lessons along the way. I then moved across to the northwest of England and took up a role in offset and counter trade, which is a department whereby when we're supporting export campaigns all around the world, we generally have to put work into those receiving the customer nations. It's something we still have to do today. And indeed, the international partnerships elements of this program is a key element to all of that. So did that largely from a commercial and contracting perspective. And then, as you can see, from about 2003 onwards, I've moved into effectively commercial type roles. And commercial over in the UK and BAE Systems is the contracting and the estimating. So making sure that the contracts we put in place with the various customers are fit for purpose, deliver a good return to the company, but also meet the customer requirements. And widespread knowledge in that. So spent time out in the Middle East, Africa, Europe. I then came back because everything I'd done to that point was very export orientated, and everybody decided, well, okay, we're going to continue to move on. You need to just do some work in the UK. So spent a bit of time doing UK large aircraft, and the real key thing here was that we were introducing availability contracting at the time, and so that's right back in 2006. So that was on the VC-10, the Nimrods, and the E-3D Sentries. And it's that availability contracting that today is actually very much a foundation to the PBLs type work we see in the US. And indeed, it's one of the key things that BAE Systems has brought to the program. So then moved over to the Typhoon program. Obviously, working in BAE Systems, it's hard to not spend some time in Typhoon. And I went in to do that also from a support perspective. I signed the first Typhoon availability service contract with the UK MOD back in 2009. And that was a 5-year contract, an output-based contract, and a very key one to deliver cost-down savings. Again, something that's of significant interest to the program as we go forward on F-35. So then after that, spent a little bit of time in, actually dabbled in procurement for a while, a bit like Eric. And decided that wasn't necessarily for me, so moved on to F-35 and have been there since. So whilst I don't have the depth of sort of F-35 experience as my colleagues on the right, in BAE Systems, 6 years is quite a good while to be on a program. And actually, it's looking like I'm going to be on it for another 2 or 3 years because I've just taken on a role of Vice President of US Business. And that's primarily to look at 3 things. So to ensure we maintain the very strong relationships we have both with Lockheed and Northrop, but also the other partners on the program. To lead the people that we have from the UK perspective out in the US. So I'll be actually based in Fort Worth for the next couple of years. Also leading the strategy for BAE Systems across the program. And then finally, to try and grow from a business development perspective and the opportunities outside of F-35. So quite a far-reaching sort of perspective, but one that will hopefully be very interesting and in a good time frame on the program. In terms of my single slide, I just thought it's worth 5 minutes on what we actually bring to the program, or what we brought to the program. It's not necessarily current, obviously, anymore from where we stand, but at the start, as Jeff mentioned earlier, Stouffville and the B model of the jet is probably one of the biggest challenges within this jet. And we obviously had the experience from our Harrier days. So Harrier design development was right back in the 1960s in the UK. The pilots who we know many of who have flown a Harrier, it's a real challenge. It's very physically difficult as well as mentally difficult. So we have several pilots on the program who have supported JD over the time. And I was talking to Peter Wizard Wilson there a few weeks ago, and he did a little brief at a conference that Eric and I did, and actually he stood up and he said, right, so when I'm flying an F-35, well actually I just press a button, stick my hands in my pockets, and it just does what it needs to do. Whether that's landing, it's whether it's it's a lot of the automation has nowadays got to such an extent that the pilot's workload has really been reduced so he can concentrate on the operational environment around him. So that whole Stouffville experience, we were quite far on in advanced manufacturing with Typhoon at the time. And again, particularly the more detailed manufacturing. Typhoon is produced in Germany, Spain, Italy, and the UK. So when you bring any of those sections together in the final assembly plants in each of the countries, you need to make sure that all the parts are interchangeable and integrate correctly. So the advanced manufacturing processes we use, we've taken onto F-35. And I think I'm fairly correct in saying that our facilities over in the northwest of England are amongst the best in the world in terms of manufacturing techniques and capabilities. So systems engineering, subcontract management, structural tests. We've been running the main structural test facility for the program over again in the northeast of England, and we've just finished a third lifetime testing. So back to the cracks. We try and generate those cracks in that facility. Once you see a crack sort of emanating, you take it off the structural test facility rig for a little while. You work out what the repair is associated with that, and then that's what you can apply to real life as and when the crack potentially occurs. And then, as I say, the last key point is all about output-based contracting. And as we move into the world of sustainment very heavily, the government over here at the moment has got a huge interest in trying to reduce the cost of sustainment. So 30% has been tabled as a minimum that we need to get out of this cost of sustainment through life. And what BAE Systems at least can bring to that, both in terms of what we call the hybrid product support integrator and product support provider elements, is knowledge of where we've done this on other jets back in the UK and have been reasonably successful in doing so. So whilst the environment is very different over here, it's still very relevant. And I think that's all I was going to say. So
thank you, Declan. And obviously, I think from the BAE Systems US side, I think it's the first company to sign up for a performance-based logistics contract under F-35 for the electronic warfare system.
That's right. So,
and they kind of took it's explained to me, they said we'd like to be the pilot for this for the program, and payoff potentially could be huge if this works. So.
Yeah, that's right.
So our next speaker is Frank Karras. Frank is Vice President and F-35 Program Manager for Northrop Grumman Aerospace Systems, and Northrop Grumman is also the other principal partner on the F-35, and it supplies the center fuselage, plus Northrop supplies a whole bunch of other stuff for the airplane as well. Frank joined the F-35 program in 2012, and before that he was the chief engineer for Northrop's part of the F/A-18, and he joined Northrop in 1992, and I think he worked on F-5 and T-38 as all part of that. So.
That's correct.
So Frank.
Thank you, Graham, and good morning, everybody, and good morning again to my distinguished colleagues here on the panel. So I'm Frank Karras. I am the Vice President and F-35 Program Manager for Northrop Grumman Aerospace Systems. I'll talk a little bit about myself, then I'll talk a little bit about what we do for the program, our work share, for those that are not that familiar with it. But I did get my undergraduate degree at New York Institute of Technology. I grew up on the East Coast, not in Northwest England, but on the Northwest New York City. And so I did my early education out in New York. I'm a legacy Grumman employee before the Northrop Grumman merger in 1994. There's very few of us left, but I am one of them. Did some graduate studies at MIT and also at Darden in Virginia. As Graham said, I'll start in 2005, where I spent 5 years as the chief engineer on the FA-18 programs, predominantly the Super Hornet program. The Super Hornet program, which is the E&F, started SDD in late 1991. I started in 1992 on the program. I was an air vehicle IPT, worked my way up and became the chief engineer in 2005. So really good program there. Spent a long part of my career understanding NAVAIR tactical aircraft, and it was a great program as well. After that, I went back and spent some time in the engineering homeroom. I was an executive director to the vice president of engineering. At that time, we had about 23,000 engineers across the country, so that was a pretty significant opportunity for me to see what the non-program side of the business looked like. Spending a long time on the FA-18 programs, going back and seeing what the functional side of the business looked like was really good for me. It gave me an opportunity to sharpen my skills on the people side and learn some different things, and which was good for me for my next position. In 2012, had the great opportunity to come work on the JSF F-35 program. At the time, I was the deputy, and the SDD program manager combined. It was a dual position. And great opportunity there, obviously, to learn the program. And I can honestly tell you, there, in the over 30 years that I've been in the business, it's gone pretty quick. But certainly the JSF F-35 program is like no other program I have worked on in my time in the business. Based on everything you heard Jeff say this morning, and based on a lot of the discussion that you've heard here from the panel on the different intricacies of the program, from the complexity technically to the governance structure, to the PSFD MOU, as my colleague John here talked about, and the alignment of all of the international partners on the business, on the program and the business, and then bringing on the FMS customers. And really, we've only just begun. Jeff talked about 300 aircraft delivery. We run about a year in front of the Fort Worth assembly operation, so we just delivered our 400th center fuselage not too long ago from our factory in Palmdale. And we just started our 500th center fuselage in assembly in Palmdale. So talk about numbers, right? Talk about big numbers here. So we're already building our 500th center fuselage in Palmdale. So we'll talk a little bit about what we do for the program. Predominantly, we build the center fuselage. We also do the radar, as Jeff talked about. We do the directed aperture system, or the DAS, and we have responsibility for the CNI. Those are the big components. Okay. So what I wanted to do here is talk a little bit about my reflections on the F-35 program and the partnerships that we've created over time, and some of the unique things that we've done as a industry team, working obviously very closely with the JPO as well. But something I wanted to talk about here was what we did in SDD. We had something called a best athlete approach, and what a best athlete approach is we had, dependent upon who brought the best value to the position, we had Lockheed Martin people working for Northrop Grumman people in certain positions. We had Northrop Grumman people working for BAE people in certain positions, and of course we had Northrop Grumman and BAE working for Lockheed Martin in certain positions. But certainly best value, whoever was the top talent, got the position in the org structure, and we did that quite well during the SDD time frame. And I say they're single enterprise comprised of industry partners, which for me was quite unique. I had never seen or been part of an organization structure like that, but there was a commitment to best value. Who brought the best value to the position? We did the same thing in something we call TFE, Team-Made Furnished Equipment. This is where early on in the program we decided who was going to do what based on, again, best value, who had the most experience with different systems on the airplane. I'll talk about what we brought to the table as Declan did from a BAE standpoint, but Northrop Grumman brought our carrier-based aircraft experience to the table. Not only with the Super Hornet program, but going back to the F-14s, E-2Ds, EA-6s, A-6s, Northrop and its partners from Grumman Aerospace brought a lot to the table there, and Lockheed Martin realized that, and we picked up the expertise in certain areas. Talk about the fire protection system, as well as the arresting gear system is another example of what Northrop Grumman brought to the table, working closely with Fokker Landing Gear in the Netherlands. Low observables, obviously Lockheed Martin has a great amount of experience with low observables, but so does Northrop Grumman, with our legacy experience from obviously the B-2 program and some of the newer platforms there. So we brought some great capabilities, working very closely with the Lockheed Martin team, putting together this marvelous 5th generation aircraft. JD talked about this, the Integrated Test Force at Pax River. We actually had Lockheed Martin team leaders leading certain aspects of the flight test program, but then we had Northrop Grumman leaders leading other aspects of the flight test program. And as Declan talked about, we had BAE leaders leading certain aspects of the program as well. So we really did a good job on this program from creating a real partnership based on best value. And we took that across the business, as you can see. Some of the other things I'd like to mention, you know, some of the other great things I think we're doing as partners on the program. We have a global production and a global quality council where we get our leaders together from these two very important areas as we start to build up in rate. And also work directly with a lot of our key suppliers where we meet on a regular basis with our quality vice presidents and our quality leaders, not just from the industry team, but from all of our key suppliers. We meet on a regular basis and we talk about zero defect planning. We talk about lessons learned throughout the industry. This is another great practice that this team has put together. Then of course there's you know, as a great industry strength as we are, three big aerospace companies, we're able to leverage our supply chain as well with right-to-buy agreements that we put in place. That also has helped the affordability greatly on the program. As you heard Jeff talk about this morning, I think a 60 or 70% reduction in price through Lot 10, and then Lot 11 is going to be some significant step downs as well. And then finally, I think Declan, you touched on it as well, something called the hybrid PSI, Global Sustainment Strategy, how the partners and the government, the JPO, are putting that strategy together, doing things differently than we've done in the past. Our logistics strategy is definitely different. And in that, we're creating partner of choice outcomes as we develop something called PSPs, product support providers, and those sorts of things. So that's my reflection back. If I had you know, time, only had 5 minutes here to talk about some of the really great things that the industry team and the Joint Program Office have done over the years on this program, those would be my highlights.
Sorry, thank you, Frank. I appreciate that. If you have any doubts to the contribution that the Heritage Grumman or the Grumman Heritage made to the program, then the paper or the session that deals with carrier suitability testing and the issue with the landing gear with the tailhook really does show where that experience came to bear in solving that problem. Just shows you that all that years' experience never really is lost. It's always somebody somewhere that still has that experience. So our final speaker is Tom Johnson, and Tom is TJ, I think he's called, is Chief Engineer for Operational Military Engines at Pratt & Whitney, and Pratt & Whitney produces the F-135 engine for the F-35. Like JD, he has 23 years experience on the program from JAS through the JSF competition to the F-35 development and production. He also has experience on the F-22's F-119 engine, which formed the basis for the F-135. He joined Pratt & Whitney in 1979, and he's also been chief engineer for the F-100 and for the PW4000. So, TJ?
Thanks, Graham. Good morning. So I grew up in Tampa, Florida, and graduated from the University of South Florida, and a little known fact is our F-135 director for the Advanced Multi-Variable Control, Louis Celeberti, he also went to the University of South Florida, so we've had an impact on the F-135 for sure. I did start on the program when Pratt & Whitney still had all of its military engineers down in West Palm Beach, Florida. And so I did work the CDA preliminary designs. And Graham, my slide is misleading because in 1997, my management decided to rescue me from the horrific beaches and sunshine of Florida and shipped me up to Connecticut to work on commercial programs, PW4000. So that gap after 1997 up till 2002, I was doing other things as well as shoveling snow in the winter time. So in 2002, Vice President of Engineering Art Lucas appeared in my office early one morning and informed me that I was the F-135 Systems Engineering Director, which effectively was the chief engineer, as my dear colleague, no relation, Steve Johnson, the named chief engineer, began to work a SWOT effort on cost and weight on the propulsion system. So Steve went full-time cost and weight. As Systems Engineering Director, I effectively was chief engineer. Later, Steve moved on. I was named chief engineer. And right on up till the day I retired, March 31st, 2015, I had responsibility for the F-135. And I certainly was there for all the hard times, and there were a few, but I was also there for some of the great times. And so it's been kind of a dream career, frankly, and Bill Reardon, the head of propulsion at NavAir, he got me on the side when I started to get to know him, and he said, "You have the best propulsion job in the world." And I kind of cleared my head and I went, "You're right, I do." And that's how I felt about my role at Pratt on 135 supporting the F-35. So it was a really great job. And I'm privileged, as JD called me up to help bring that experience to this forum, I'm privileged to represent Pratt & Whitney and, to the best of my ability, my colleagues at Rolls-Royce in the forum. I had one slide. It's not particularly about partnerships, but there's an awful lot of partnership going into designing, developing, and qualifying a fighter engine, and a STOVL one alongside it, no less. Achieving the initial service release for the two propulsion systems was my favorite propulsion system moment in the program. Just an incredible effort, almost 24,000 hours of development testing, and you can read the other factoids there. But great moment in the propulsion area, supporting the F-35 program. So when I got the call from JD, I was in deep conversation with my twin 2-year-old boy and girl grandchildren, and I stood back from that and went off and I started to think, well, what are my reflections on partnership in the F-35 program? And my reflections were pretty generic in nature, so I'm going to share them with you. And I do have a passion for teaching. And I like to teach actively on the job, but I also know there's a lot of indirect teaching by how you lead in technical meetings or otherwise. There's an awful lot of indirect teaching, as I know, as I witnessed growing up at Pratt & Whitney and learning from people with much greater skill than I had at the time. So I offer these comments, especially to younger engineers who find themselves in complex partnerships, developing complex products in complex cultures in many parts of the world. So, so working together is what I think of a partnership. It's working together. I'm married, that's a partnership. My wife and I work together. Working together has to be right near the top of the critical ingredients for program success. And you can see the success of this program here in 2018 as my colleagues are demonstrating that. Working together, it applies to companies and organizations as well as people. And the trick in a big program like this is getting all three functioning. So when I think of the F-35 program, why do we need to work together so well? It's the complexity. The complexity of this program is just hard to grasp in a few minutes if you have not worked on this program. So there's product complexity. There's 3 different aircraft, and there's 2 different propulsion systems, conventional and STOVL. There's development organizational complexity. There's 3 airframe companies: Lockheed Martin, Northrop Grumman, BAE Systems. There's 3 engine companies: Pratt & Whitney, Rolls-Royce, and up until 2008, General Electric with the F-136 engine. There's customer complexity. We have the U.S. Air Force, the U.S. Navy, the U.S. Marines. They are different customers. We have the Joint Program Office working to pull that all together. And we have the international development partners who not only funded development, they helped with a lot of the development. So customer complexity requires working together. And finally, I thought about, well, how many different locations is the engineering done on this product? And it's worldwide. And just for me alone, based in East Hartford, Connecticut, we tested our propulsion systems at AEDC government facility in Tennessee and in West Palm Beach, Florida. Our partners, Rolls-Royce, were based in Bristol, England, and today the program lead is in Indianapolis, Indiana. And of course, the integration of the propulsion systems comes together in Fort Worth, Texas. So definitely location complexity to deal with. So I asked myself, how do we work together to manage this complexity? Because that's where the success comes from managing this. And there's no doubt you better have well-defined, efficient processes and associate contractor agreements, because that is ultimately how your teams are going to execute. And the better defined they are, the smoother they are, that will help your program. A couple of good examples on this would be our interface control document, where the propulsion system is integrated into the aircraft. And we had a good process on that. The specification working group is always a vital and critical partner process as you develop the product. Second critical success factor on working together is to have a talented, excellent, and driven program engineering team. And in my opinion, I have not met a finer team than's on the F-35. There are just some unbelievably amazing and talented people, incredibly dedicated to making these partnerships and the program work. I found that when the work slows down, especially if a partnership is involved, your joint management meetings, the meetings of the managers on top, getting together to understand those issues that the teams are having and making decisions if they need to get them unstuck, that is a critical element of partnerships and working together. And finally, being able to follow those decisions. Everybody, after the decision's made, everybody go off, no matter what part of the partnership you're from, being able to work together and go execute those decisions, that's definitely key to bringing the kind of successes that we're seeing here. So I just wanted to share that generic perspective, having been on the program for quite a long time, and as I observe those, I hope that will help, especially younger engineers, understand the big picture that you might find yourself in.
Thank you. So we'll move along with the questions now. So I have some that I've prepared already, but obviously I'll try and combine them where possible with the ones that are coming in from the folks, and ask the ones on the tablet here. So JD, I wanted to start. Oh, it's just disappeared. I wanted to start with. So the development test program was planned as 5,000 flights, and that was based on anticipated flight test efficiencies, not just from having 3 variants of a single airplane instead of 3 different airplanes, but also you had hopes of being able to just be more efficient at flight testing, not as many reflights and things like that. It ended up as 9,200 flights. So what were the challenges that you encountered during flight testing? And how did you overcome them? And then there's that sort of ties in here, which a question from the audience was, what caused the most concerns and reflights? Because that obviously was something early on that you were hoping to avoid.
Right. Well, I'd like to say that the reason we had to do more was all Tom Johnson's fault, but it really wasn't. The propulsion system actually worked quite well during the program. We did have a few issues with propulsion that would cause us delays, but probably not the #1 reason. It's important when you talk about deltas from plan to actual, you understand what baseline you're talking about on the F-35 program. So it is right, we did start with a little over 5,000 flights at the very, very beginning, coming right out of the proposal. And in the proposal, for the Joint Strike Fighter program, Boeing and Lockheed Martin competing, the JSF program office really did not want the flight test program to be a big discriminator on cost, because the government costs of the flight test program could have been a big discriminator had we planned radically different programs. So the number of jets you could have, the test sites you would use, and really the span of the program were fairly well defined, because they declared an IOC date going into the proposal, and you can only build the first airplane so fast. So we both had a program that was close to 6 years in duration. We had 14 jets at that time. So up until we really did our first flight, we replanned that program numerous times. And the first one was because of the SWAT program. Stowable Weight Attack Team, our first airplane, AIAA, really became kind of a prototype of sorts. We flew 91 flights with that airplane. We kind of put it to the side. So we had to add an airplane to the program. So we went up to 15. We also reordered the program at that time. We put the hardest airplane first, switched to stowable as the first airplane. Fast forward a few years, we were running into cost programs, and so we did what was called MCRR, mid-course risk reduction. That time we thought, hey, we don't need all these jets. We deleted 2 of them. And so there's no AF5 and there's no CF4 on the program. We deleted them, said we didn't need them. We'd combine test assets and accomplish what we needed. So we had 13. Well, then we went through the Nunn-McCurdy program, and over that year, plus a little bit of replanning prior to that, that was really done when we only had 3% of the flight test program done. So the baseline that came out of that added 5 more jets to the program. So we had the 18 aircraft at that time. The F-136 alternate engine program, we got canceled at that time. I know that's one of the questions. I'll touch on it later. So we really had to rely on the F-135 for all our support in flight tests. So that was one thing that is a lesson learned I'll touch on later. So those 18 airplanes, we replanned the programs, increased the span, and had about 7,700 flights that came out of that technical baseline review as our baseline program, and said it would take into 2017 to finish the program. So that's what I look at when I measure what was the baseline. Well, it turned out to be 9,200 flights, or about 1,500 additional flights. When you look at where that difference was, the flight sciences part of the program, which had 2 or 3 jets on each variant, only did a couple hundred more flights than what was planned. On the A model, really, we didn't run into any significant problems on that. It was really about as planned, about 1,700 flights, and that was the first one to finish. The Stovall variant, it had about 2,500 flights, a couple hundred flights more than planned. And really, I would say that was because we ran into the challenges of all the doors on the program. There are multiple doors that open up when, as Whizzer said, you push one button and the transformation takes place. We have an upper lift fan door. On the lift fan, that was one of the main changes we made going from X-35 to F-35. We affectionately refer to it as the 57 Chevy hood because that's what it looks like. When you've got that big door in the stream, it creates several vortices coming off of it. Those vortices hit the next 2 doors. Behind it, the aux inlet, and those 2 doors fold outward. And so any side slip on the airplane greater than about 5 degrees would cause these vortices to hit those doors. Lots of vibration would take place on those doors. So we had to kind of pause at that time. We couldn't expand the envelope at that time and had to go redesign those doors with the help of Northrop Grumman, and came up with a much better design in hindsight. Same look externally, but the internal mechanism is all different. So the extra work we had to do with that drove some of that. And then on the carrier variant, the number of flights we had to do didn't grow too much, but we had to have a pretty significant pause in the program in the development of the carrier suitability and basing and ship suitability because of the tail hook. We had to pause and redesign that. Henry Melton, one of our leaders from Northrop Grumman, led the carrier variant testing up at Pax River, and one day I got a call from him. They were at Lakehurst, said, JD, this tail hook didn't catch the wire. We'll try it again. And so later that afternoon they called, hey, we didn't catch the wire again. Well, there must be something wrong. Go check everything. Next day, hey, it didn't catch the wire. What in the world is going on? And Henry had quite a bit of expertise. He goes, we're going to have to redesign this thing. I said, no way, y'all are doing something wrong. Well, turned out it needed to be redesigned. Go to the carrier suit presentation and you'll hear what we had to do for that. But that was really several years that we had to delay on that. But those are the main changes, I guess, from the plan to the actuals on flight sciences. The rest of it was on mission systems. Mission systems testing ended up being about 1,200 more flights than planned. And it really turned out to be regression driven. Every time we changed the software, you go in and make sure that the change you made fixed what you were trying to solve, and then you do a lot of regression testing, make sure you didn't mess anything up that used to be working, make sure it's still working. So Dr. Fry's fusion algorithms, highly complicated. You could change something in one area and have an impact in others. So we had to do a lot of regression. The entire Block 3I program, which took the Block 2B software, put it on this new TR2 hardware, the integrated core processor, the new computer system, and ported it over. All of that was regression. No real new capability between Block 2B and 3I, just running on different computers. We did about 500 flights on that. We had no idea it was going to take that much regression. So all that was addition. And then we just had a lot more software drops than we ever planned from the beginning, and all that regression that we did. We also did mission systems testing in the signature area, testing the signature of the jet year over year. So as the program extended out, we did a little bit more of that. I think the other question was relative to how did the F-136 program.
I just want before we leave the flight testing. Now, when I read some of the papers, you did find more efficient ways of doing flight testing, didn't you? I mean, you did learn how to be more efficient in flight testing.
Absolutely. I think one of the lessons learned, it's very critical, track what happens every single day. And we did that quite meticulously. Every single jet, what happened to it today, why did it fly, what did it fly, or was it down, why was it down? And then over time, you get to learn what is it that's causing us not to fly. Number one reason, weather. Why in the world the Navy picked a flight test center in Patuxent River, Maryland, I don't know, but the weather's not perfect there compared to California and the high desert. So we planned that when we went through the technical baseline review and had all that built into the program, but that turned out to be the number one driver for why you didn't fly. Number two driver was any asset that you needed, typically government furnished at those ranges, some issue with it. And when we do these complicated missions, you need tankers, you need drones, you need assets on the ground to be up or assets in the air that you're flying against. So we would do single ship missions, obviously, in flight sciences and in the early days of mission systems, but there towards the end, 8 ships of F-35s and another 10 assets in the air in a support role. And to get all of those to work at the same time became a challenge. And so as we learned what happened in flight test, we went and attacked those issues that drove us. Some of the systems on the airplane, obviously in the early days, had to go through redesigns. Those made it on the production jets in the early lots. And so we went and intentionally changed all those parts out on the early SDD jets. That increased our aircraft availability and helped us to fly more efficiently.
Okay. Now, okay, I'll let you address the the other engine.
Yeah, so the impact of the F-136 program was the question relative to how it impacted the program or flight test?
Can you comment on, just says, can you comment on the impact of the fighter engine team alternative engine, the impact on the program? I mean,
sure. Well, I mean, as TJ mentioned, they were a big part of the program from day one, and so the vision was you're going to take out this engine, put a different one in, you're going to use the same lift fan, same roll post, same 3 bearing swivel ducts. So Tom mentioned the interface control document that we had between the propulsion system and Lockheed Martin. It has about 70 physical interfaces with the airplane, but there are hundreds of functional interfaces. The F-136 had to do the exact same thing. So partnership, the 3 main companies got together and ensured that we were all designing to those same requirements. Then there's another interface control between really Pratt & Whitney and General Electric. We had to match up with the lift fan, roll post, and 3 BSD. So same cooling flow to the liners, the same speed that you had to rotate the lift fan, same airflow to the roll post. And they design engines differently between Cincinnati and West Palm or East Hartford. So not all that was identical, so had to account for that. So we did that for most of the 2000s, and there were lots of lessons learned that GE gained through our early work, and then they brought technology to the program that we got to apply as well. The program, primarily due to cost reasons, the government decided they couldn't afford to program, so it was canceled. We had planned an F-136 integration program in flight test, and they had about 8 engines that were going to help us. When the program got canceled, we did not replace every F-136 engine with an F-135, saving money. We just let those F-135s go longer. And as it turned out, TJ had to continually extend the life of the F-135 as we got into the flight test program, because we never intended those engines to last that long. And so they were, all the test assets were gone, so they had to do a lot of analysis to extend that, and we've used those engines all the way up to the end.
Cool. John, the F-35 program, it's a partnership. It's a partnership between the Joint Program Office, several major aerospace companies, Lockheed, Northrop, BAE, Pratt Rolls, multiple countries, as you've said, and within countries, multiple services. What was, from your viewpoint, what was the most challenging for that partnership to make it work. And in the end, frankly, I mean, was it a good idea to try and do a program like that? I mean, when you look back at what you've learned, was it a good idea from the ground one to tackle a program that way?
Let me answer the last part of your question first. Was it a good idea? And I would say yes. It's been really hard. It's been very painful at times, but this is my personal view, I think when we all look back on this thing, we will all say, yeah, it was absolutely worth it to have brought together all these countries and these industries. And I'll focus on the countries really more than the industries. They have been a part of every decision made on this program. The U.S. government has recognized that, I'm not sure who else said it, but this is the most expensive program for many of these countries that they will, in their history, have made. So it's not just a Defense Department or military or Ministry of Defense decision for most countries. It's a political decision. Do I make this massive investment in this weapon system? So that conversation that we've all had to have, I think, has been good for us and will especially be good when these, jets get used in anger in some point in the future. To answer the what's been the most challenging or the most difficult, I would say it would be the disclosure of the information or the security of the information that we've had to go at every step of the program. When I first joined the program office and we had, Dutch and Brits and Italians walking around the program office, that's kind of a shock to the system for a lot of the security people to say, yeah, that's okay, he can be here. And then when you put a slide up there and everybody freezes and says, is it okay if the Italians see this? And because our instinctual thing for a 5th generation fighter, the leading edge technology is, the crown jewels is you want to protect it. And here we're saying, no, open the doors, let everybody in, let these 8 partners wander around the program office and be fully exposed to this information. That's hard for the security people. And the security is not just inside the program office, it's prevalent through all the Department of Defense and into the State Department. So then when Lockheed or BAE or Pratt & Whitney says, I want to share this manufacturing technology with, what was the number, 16,000 industrial partners around the world, that means an export license has to be put in place, and that means somebody has to scrutinize every piece of information that is going to flow out of this program into, somebody that talks different than us into their hands. So breaking down those barriers has been a challenge from the start, and that challenge, it's not over because we're moving into another phase of the program, more advanced development. So we're going to continue to have to scrutinize every piece of data and technology and manufacturing know-how going forward. So challenge isn't over.
Was it, just very quickly, was there something that could have been done early on to make it easier? So if somebody's thinking about doing, we have several big programs coming out, whether it's Future Vertical Lift or whatever. Is there something that they could precondition the program that would help?
You have to, in my opinion, you have to precondition the whole system. And so that's the disclosure community, the export licensing system needs to, I think, get together and go, okay, what are the most the technologies on this system that need to be protected the most? And let's make sure that those are well protected and let go of the rest and be clear up front so that industry has got a clear path forward on what we hold dear and what we share.
Okay. Eric, the F-35 program set out to break the mold of the traditional industrial offset work for contract type thing. What was most challenging as that evolved? As you evolved the supply chain from the initial supply chain as you evolved, what was most challenging about maintaining that model of breaking the mold? And then obviously you evolved it from development to production, and now you're going into sustainment. Has that sort of best value model that you started out with, has it survived? Has it endured and matured through that?
So the program, as you recall, was always established on a best value approach, economy of scale, build as many airplanes as you can, and that allows you to liquidate a lot of the costs. So John indicated, started out from the very beginning of the program, before it was even awarded, putting all those multilateral agreements together with all the partners. Now, those multilateral agreements, once executed with the 9 partners, US and the 8 internationals, was another fundamental cornerstone. That gave them immense privileges and accountability. Privileges. They were inside all of the requirements establishment for the program, so they were bought in from the beginning. They knew what they were going to get. They had the ability to influence what that product was going to be in the end, and that was from the start. Accountability was establishing that best value, industrial enterprise, and the best value. Once established, each of those partners, based on their buy-in, they had a expectation, a defined expectation on how much industrial participation they would reap from the program over its life. And then it was managed as a program. Just like you do any other aspect of the technical parts, this was managing the industrial enterprise or political aspects of it. And that was a part of the program that we measured from day one. Now the accountability model really extended further. The best value approach fostered immense amount of competition. We found out where the best value partners were internationally, what they could do. And the way the best value model was established was, it wasn't whether you won it, it was whether you had the opportunity to compete. So we offered them levels of participation, and it was up to them to demonstrate through the costs of their involvement in the program, whether it be at development, production, and now sustainment, were they best value? So the competitive element is a hallmark of any large industrial enterprise, and that introduced it from the start. So I think by and large, it has been very successful. Many of them competed on a playing field with several of their peers and won the business. Many of them are still on the program since the start. They're part of that whole ecosphere of providing material to the program, and now we're embarking on a similar kind of thing for the sustainment side. And the proof, the outcome of the best value work is really where we are now. Of those 8 international partners that started with us, all of them from 17 years ago are still here. And of those 8, 7 of them have bought airplanes. There's only one that's still in their competitive decision-making process, and they'll go through that, and based on what their national sovereign needs are, they'll decide. So that's one. They're all still with us on the program after 17 years. The last part of it is it working? So Jeff showed the chart, 60% reduction. We all said we were going to go deliver 4th gen price with 5th gen capability, and we continue to work towards that path together as an entire partnership team.
So I've got a question here that's well up the list here, is just asking a question about whether the assembly lines in Italy and Japan, are they identical to what's in Fort Worth, and therefore is there a potential that they could be used, if you needed to either increase production or target production or distribute production? Are they literally identical to what you do in Fort Worth?
So we set both of those parts up now. The two are slightly different. The one in Japan is only a final assembly and checkout facility, so it just builds the basic F-35. The Camry facility builds both wings and has final assembly and checkout. We looked at each of them and had JPO experts at the same time make sure that they could develop or they could deliver a product that was identical. There was a whole assessment of it. Do they do it exactly the same way? No, but the outcomes are exactly the same. And we do look at those from time to time to say, can we use them for additional capacity, as well as both of them are well positioned in those two theaters in Asia and Europe as MRO and U facilities where you already have infrastructure, you have a trained workforce, you could do heavy maintenance on the airplanes in those locations.
Okay, I'm going to jump in with one from the audience here because it's been voted up well up to the top, and it really goes back to the international partnership again. And if the question is, do you anticipate disruptions to the F-35 program resulting from tariff tensions between our traditional allies? Is there any concern for an impact on the program?
We've looked at that several times recently since the tariff issue came up. Many of our agreements are long-term, up to 5 years. So we buy the materials and we have long-term agreements that tend to stabilize those elements out. The other aspect of it is those taxes and tariffs are largely on aluminum and steel. Those are, quite honestly, the raw materials are a very small percentage of the cost of the airplane. So we have long-term agreements to normalize them out. They're not a big percentage of the cost of the airplane. It's down in single digits percent. Most of the cost comes in the value-added work of machining, labor to assemble, and all the other aspects that build up the aircraft. So we don't see that as a long-term impact that would disrupt that partnership if we're continuing to build the F-35s.
John, any impact from your side of things?
To date, I would say no impact at all. And then the other thing I'd add to what Eric said is the way the agreements are set up is taxes and tariffs are borne by the country that would apply them. And so, for instance, if Italy said, okay, we're going to charge a 15% value-added tax for materials coming into our country, the agreements are such that they would actually have to pay that 15%. It wouldn't come out of our pockets.
So Frank and Declan, could you sort of talk about how the respective strengths that each industry partner brought to the program, how did they help tackle when you had specific challenges? What, I think we've talked about some of them, but where those strengths, the company strengths, were able to be brought to bear. And did the nature of the partnership evolve over time in terms of, I know that, obviously there was, as the development program extended, there was, the US, I think, picked up most of the tab for the additional costs. Was there any sort of evolution in the relationship or the partnership as you went along? And then how does that evolve into the follow-on development? Does it just roll into the development and sustainment? Or is there a different approach? I mean, whichever one of you wants to go first, let's talk about the partnership side.
So I think it's probably slightly different from our two perspectives, but from the UK perspective in BAE Systems, we talked a little bit earlier around the strengths we brought. So back in the workshop we've got is largely around the manufacturing side, so the aft of the aircraft, the vertical tails, the horizontal tails, and the outboard wings and the CV. So we design, manufacture, and assemble all of those particular components. We also bring to the table the crew escape system, life support, and fuel systems that are probably the key ones. So that work has, been a heavy amount of the value we've brought to the program up to now. What's changing as we go forward is the pressure on, say, affordability going forward in terms of what we call delayering. So having got to a point in the program whereby you've provided these systems in the past, it's not necessarily a guarantee that you'll be able to continue to do so going forward. And for example, the seat has recently been taken from us, and it's just effectively because we don't add value anymore in the seat production, or not of a significant nature. So Lockheed will buy the seat directly from the seat provider, and as such, that particular element of the scope of our work has changed. But what we are looking at in sort of in comparative terms to that is through Brexit, the sterling / US dollar exchange rates changed quite a bit. So manufacturing in the UK is probably now cheaper than what it has been in the past. So we may be more competitive in some of the manufacturing type work, And so we would compete for that on the basis of value add. And if we can get more of that sort of work, then it sort of equalizes where we would have originally been. If you go to development, development's interesting because it goes back a little bit to what John was saying around the disclosure. A lot of the future development on the jet is going to be heavily around mission systems, a lot of the sensitive avionics. So BAE Systems Inc., our US companions, they provide electronic warfare, for instance, to the jet. So they will be heavily involved with follow-on modernization, or C2D2 as we call it. But in the UK, the fuel, the sorts of the systems we've been involved in the past won't necessarily have significant advancement. So we're in discussions with Lockheed around, can we change and can we get other bits of development? But it's not easy. It's not straightforward because of the mission systems and sensitivity of that work and the disclosure side. So the face does change from an industrial perspective as you go through its life cycle, and where we're probably focusing more of our efforts now is on the sustainment bit, because off-board and the skills and knowledge and experience we still bring around sort of sustainment is still very key, and that's a key element going forward in terms of price reduction, and that's something we can still bring a lot to the table. So it rebalances sometimes across the different design, development, and production.
Frank?
Yeah, so from my perspective, I'll touch on something that JD brought up in the flight test program, where we had an arresting gear system that didn't catch the wire, right? Big problem, obviously, and we couldn't figure out why it wasn't catching the wire, but we had a subcontractor who had design responsibility for that. That was under Northrop Grumman. It was one of Northrop Grumman's subcontractors. When we had the issue, we were able to leverage the greater strength of the company, not just F-35 program engineers, but we reached out to all parts of our company on expertise with carrier suitability and carrier landings. And we were able to jump in, and working with our subcontractor, we did not take design authority, design responsibility, test responsibility away from our subcontractor, but we were able to partner with them, and personally I was part of that. Actually, I spent 6 months in the Netherlands working with that subcontractor in a complete redesign of the arresting gear system, and that was a significant challenge for the program. It came down to, honestly, a cable dynamic issue based on the short length of the arresting gear on this program, because we do have a centerline engine, and the tail hook on an F-35, if you go look at an E-2D or an F-14, the tail hook on the F-35 is significantly shorter, and that created some challenges for us, which we didn't realize when we first put the configuration of the airplane together. So yeah, I mean, and Declan brings up a good point. Over the evolution of the program, we've had to take a look at some of those systems expertise, best values that industry has brought to the program. And we did some resetting of systems that originally were either Northrop Grumman or BAE. We looked at it. Decision was made back in maybe 2004 to go this way. Now in 2012, okay, here we are today. Does this make sense? Is this the right thing for the program for Northrop Grumman or BAE to be doing this, or vice versa? Is it the right thing for the program for Lockheed Martin to be doing something? Does that expertise now change hands? And we did that in 2016. We did what we call a TFE reset on the program, and some of the major systems moved from hand to hand. As a partner, an industry partner, as we both are, we have teaming agreements with our customer, Lockheed Martin. So when we did that, when we said, okay, this is best value, let's do this, now we're looking at some other things that maybe Lockheed Martin or BAE is doing today. Maybe it's best value for Northrop Grumman to be doing that. So we're constantly looking at that as a best value, most affordable opportunity for our customer. And then I think the last part of your question, Graham, was about sustainability. I mean, logically, you know, we will maintain our systems, the systems that we have design responsibility for today and authority for. We'll do logical, you know, PBL strategies for those. We want to provide the best, most affordable solution for the program. Whether that means it's Northrop Grumman or BAE, I think as industry partners, we're always looking for best value for our customer. It's not about personal pride of company ownership. It's about what is the best solution for the program and ultimately for the warfighter.
So I have a question for TJ, but it sort of kind of fits with one that's up near the top now, which is about how do you manage communication and collaboration between the teams. And so TJ, I mean, what I wanted to ask, and maybe if anybody wants to jump in after TJ has commented, but the integration of propulsion and airframe was very tight on the F-35. It's a small airplane with a lot of stuff packed into it. And obviously the Stovall system was particularly complex. So how challenging was it to have to literally work so closely with Lockheed Martin and with Rolls-Royce to get this to work? I mean, it's not, we probably haven't worked this closely on previous programs, or maybe not, I don't know. But was there anything particularly learned from that? I mean, as to how you made that work?
Well, quite honestly, it was a pleasure working with both companies. And I used to tell my team in private that Lockheed Martin makes us better. They make us better than we are. They make us stretch more than we are already stretching. And when I look back, when we were on Stovall probation, for example, we pounded out some stuff with our Rolls-Royce teammates, and that helped exit that phase of the program a year early. And I really took that statement to heart about being made better, so that was exciting. We've worked with Lockheed Martin for a long time. We have the F-100 and the F-16 aircraft, the F-119 and the F-22, so our companies are pretty conversant with each other. And with Rolls-Royce, we've had many excellent successes together. One is the IAE V2500 engine, which Pratt has the predominant share for the engine, and the Rolls-Royce compressor is part of that. So we've worked to integrate complex products with Rolls. And relative to lessons learned, both lessons learned that come to mind involve time and going quicker, the need to go quicker. And early in the program, JD and I were arm wrestling over several components about who owned them, who should own these components at the interfaces. One in particular was the lift fan anti-ice control. And we worked all that out, and I think JD's simple to remember guidance is parts that stay on the propulsion system should be owned by the propulsion system, and parts that stay in the aircraft should be owned by the aircraft. And that's effectively what we did. But getting that agreement sooner would have allowed the anti-ice system development to proceed quicker, for example. So that was a lesson learned on integration. And a more complex one was the definition of the required airflow into the lift fan inlet. And talk about a complex pressure, temperature, and flow distortion field. In order to design the lift fan, we had to know what to expect. Rolls-Royce had to know what to expect for how the air would flow through the inlet. And the first inlet design was a bifold door early in the program. And it turned out by the time all the CFD models were done and all the CFD models on the lift fan blades were done, vibration predictions on the blades themselves were beyond requirement. And that led to redesigning the aircraft inlet door into the '57 Chevy hood. And that was, nobody wanted to do that, but if we could have done more risk reduction work up front, either prior to the program or earlier in the program, or did the work that we did to identify that risk quicker, that would have let the program compress more. So those were two that come to mind on integrating, but they're behind us now, and it's all good memories.
Yeah. I might add one general comment to that. TJ and I have worked together on this program for many years, and yeah, we have formal ways in which we communicate, interface control documents, specifications. We have monthly meetings. All that is necessary, but it really is about the personal relationships that one establishes. TJ and I have been at lift fan preliminary design reviews in Bristol, England. There are pubs in England after a long day. You spend time there. I've played Skittles. All you Brits know what Skittles are, kind of bowling with very small ball. We've negotiated the weight of an F-135 after a game of Skittles, and I have a picture of that. That is really key on this entire program, the relationships you have within the entire enterprise.
Okay. Can I just take, I know we're coming to an end, but this is just the top question. I do want to ask it because it is important these days. This is an international program, lots of different cultures involved. How diverse is the question is how diverse from female and minority perspectives the program, but it should be a little bit more than that. I mean, is this a program where you've achieved a greater degree of diversity than because of all the mixing of cultures, or is there anything you can comment on that as well?
Well, yeah, I think because of the diversity of cultures, because of how international the program is, that is widespread. From a female and minority standpoint, I think the six middle-aged males up here may not be the best representation, but I think it is like all engineering industries. I think that the younger population coming into the program now, much greater percentage of females, but there have been many great female leaders on this program. Lorraine Martin was our
She was very key in re-establishing the relationship with the customer.
Absolutely. She preceded Jeff Babillon in that role. We've had a female PEO. I think of the chief engineers we've had at the flight test centers. Dr. Mary Hudson has a presentation on flight test. Both sites had female chief engineers, so we've had females in very key roles on the program.
Thanks for addressing that. So, guys, I really appreciate it. It's been a fantastic, fascinating conversation, and thanks for all your insights. So thank you very much.
Thanks,